Good morning, one and all. Today we are going to solve a problem in Thevenin's theorem and as well as the Norton's theorem. Take down the circuit. For the circuit shown in the figure, find the Thevenin's and Norton's equivalent circuit at the terminals A and B. So if you see the circuit, um, actually it seems to be a confusing circuit, but it's a very simple circuit. You can easily solve this problem. I think is that it is given in such a way that it is looking like so complex. So nothing like that. So here you will be having two current sources there. One current source is in this loop and another current source is here. And here you see two voltage sources there, 10 volts and 18 voltage sources there. And positive negative that terminal also battery source terminal also given clearly. So, what are the A and B points? Across this A and B points, we need to find out the Thevenin's voltage and as well as Norton's current. Now, solving this circuit by using a Thevenin's theorem. Now, redrawing the circuit. So, before redrawing the circuit, so if you solve by using a Thevenin's theorem. So loop analysis method. So here you see here one current source is there, one current source is there. So if you solve by using a loop analysis method, it seems to be a bit difficult. So what we are doing is we are converting this 3 amperes current source that is parallel to this 4 ohms. So that we are converting into a voltage source with a series resistance. Okay. So what I am taking is I am just taking this alone outside this 3 amperes voltage current source and 4 ohms resistance source that is connected in parallel. So connect source connected with parallel that is converted to voltage source in series. Okay, so that by using the source transformation method. So in source transformation method, so if we convert this voltage source into current source, so what is the formula? By using Ohm's law, V is equal to I into R. So current is 3 into 4 ohms. So 4 is nothing but 12 volts. So we are converting this 3 amperes current source into 12 volt voltage source, and this resistance will be connected in the series circuits. Now, so we are inserting this here. So now we are redrawing the whole circuit like this. Okay. So what I am doing is this 18 volt as it is I am taking this alone I am redrawing. So this alone I am redrawing 12 volts and as well as 4 ohms here. So rest are all same. So here 6 ohms is there. Here 6 ohms is there. Here 2 amperes current source is there. In this loop it is 10 volts volt source and 5 ohms resistance source is there. So rest are all same I am taking across this point A and B. Now we are solving by using the Thevenin's theorem. So we need to find out the open circuit voltage or otherwise Thevenin's voltage over here. Now, so for making it very simple, what I'm doing is I'm connecting this via a voltmeter here. Okay, so voltmeter here for measuring what is the open circuit voltage over here. Now, if you see this circuit, so we are solving by using the mesh analysis method. So by seeing the circuit, how many loops are there? So here, two loops are there. Okay, here one loop and here one. So I'm taking this current as I1 and this current as I2. Now, by using the mesh analysis method. So here already one more current source is there. So here what might be the current flowing in this particular loop is nothing but 2 amperes. So because the current is flowing like this. Okay, so already 2 ampere current sources giving the current as 2 amperes in this particular loop. So directly we can take we can write I2 as 2 amperes. Now just for solving this loop alone we need to solve by using this loop alone, or otherwise if you consider this as another loop and you frame the equation loop equation, and if you solve also the same answer 2 amperes only will come. You can try and tell in comments that you are getting the same answer. Like now we need to frame the loop equation for this. So here I2 is 2 amperes. So here I1. So what is the current is I1. So here you see current is flowing like this. So current is flowing from minus to plus for this voltage source. So minus to plus is drop. Again here also drop. So drop is nothing but negative. So minus 18, minus 12. Okay. So again here it is minus 4. All resistance we are considering as drop. So minus 4 into I1 minus I2. Okay. So again minus 6 into I1 minus I2. So again 5 into I1. Okay, minus 5 into I1. So the current is flowing from minus to plus. So minus to plus is raise. So raise is positive, plus 10 is equal to 0. Okay, the same thing in loop 2, I2 is equal to 2 amperes. The same thing we are framing the loop equation like this. So just simplifying this, we are getting the answer as equation as 15 I1 minus 10 I2 is equal to minus 20. So substituting I2, we already know I2 is 2 amperes, that is one loop. So or otherwise, as I said, if you frame the loop equation for loop 2 and you further solve this two linear equation, you will get the same answer. Now, as I explained, so I2 is nothing but 2 amperes. Same I2 I am taking as 2 amperes in this above equation. Now we can easily find out I1. So I1 is it is coming like minus 20 plus 20. So it is nothing but I1 is coming as 0 amperes. Okay. So there is no current flowing. Okay, it is coming as 0 amperes. So there is no current flowing in this. So it is getting cancelling out. Okay, so current is getting cancelling out. So there is no current flowing to this particular. Say for example, no current means, say for example, so what is the voltage across this point is nothing but voltage at this point is equal to VTH. Okay, so but no current is flowing. No, so here also it is 0. Okay, so the current flowing, the voltage in this particular, this 2 point is nothing but 10 volts. Okay, so because current I1 is, we calculate as 0. Okay, there is no current flowing because it is cancelling out each other, no current flowing. So only this battery source alone will gives the voltage over this 2 points between the A and B. So VOC and VTH is nothing but 10 voltage. Okay, 10 volts. So that is what we are there. If I1 is equal to 0 amperes, then VOC or VTH is equal to 10 volts. Because here there is no current is flowing, only one battery source is there, that is 10 volts. So that is giving 10 voltage across this 2 points A and B. So VOC or VTH is equal to 10 volts. So VTH is Thevenin voltage is 10 volts. Now we are going to find out what is RTH and R. Both are same, no? Because we are going to solve by using Thevenin's theorem and as well as Norton's theorem. So both are same. Now what is the rule? Rule: short circuit the voltage source and open circuit the current source. So coming to this circuit, so here you see, yeah, either this circuit or this circuit. So here, what is open circuiting this current source and short circuiting this voltage source. Open circuiting the current source. Okay. So or otherwise this circuit if you take, because this circuit only we calculate VTH. No. So all here voltage sources, two voltage sources there. So voltage sources we need to short circuit, open circuiting this current source. So here also voltage sources there, here we need to short circuit. So only this 4 ohms, 6 ohms and 5 ohms. Okay, that only this 4 ohm and 6 ohms are in series, so parallel to 5 ohms. So that's what we are redrawing over here. So 4 ohms and 6 ohms and here 5 ohms. So across this point A and B. Now simplifying this, 4 and 6 are in series. So series means it is, you need to add. So it is here it is 10 ohms. Here it is again 5 ohms across this two. So this 5 ohms and 10 ohms are in parallel. Okay. Now RAB is nothing but 10 into 5 divided by 10 plus 5. So here we are getting 3.33 ohms. So RAB or otherwise RTH or RN is nothing but 3.33 ohms. Now we need to frame the Thevenin's equivalent circuit. So what is Thevenin's equivalent circuit? So whatever the VTH we found out, so that is we are adding battery source, we are adding over here, and that RTH we found out, no, that should be connected in series. So across these 2 points A and B. So here that is no resistance is given in the problem. Okay, so only they have given us A and B. There is no resistance, load resistance is given. So just like that, we are taking A and B over here. Okay, so we are taking A and B. So this is all about the Thevenin's equivalent circuit. So in the problem also they asked find out the Thevenin's draw the Thevenin's equivalent circuit and as well as the Norton's equivalent circuit. So now Norton's theorem also we are going to find out the solution. Same circuit I am redrawing here. Now it is short circuit current. Okay, short circuit current. There it is open circuit voltage. Now what I did is I have short circuited it and I need to find out what is the IN over here. Now how to find out the short circuit current? Now the best method is to find out, you can also go with the nodal analysis, but the easiest method is to go with the mesh analysis, okay, loop analysis. So here the current flowing into this loop I am taking as I0, here as I1, I2. So already in the previous here we have taken as I1 and I2. The same notation here also I am taking I1 here, I2 here. So here I am taking this I0. Okay. So now three loops are there. Three equations will come. So we are going to frame the three. So I2 is nothing but 2 amperes. No need of calculating it. If you want, you can calculate and tell the answer. And here now we are framing the same I1. So what is the difference here is in this 5 ohms, in this 5 ohms, rest are all same equation will come. In this 5 ohms alone, we are getting minus 5 into I1 minus I0. Okay, like that we'll get. So just framing the equation. So here I1 is flowing like this. So I1 is flowing like this means the current is flowing to minus to plus. So minus to plus is raise. So raise is positive. So here it is drop. So current is flowing like this. So it is flowing from plus to minus. So plus to minus is again drop. Here also plus to minus again drop. Here all resistance are drop. So here what we are taking is minus 18 minus 12 minus 4 into I1 minus I2 minus 6 into I1 minus I2 again minus 5 into I1 minus I0. Okay, again this is plus 10 is equal to 0. That is the looping. So again this loop equation also there. Okay, so if you see take like in loop 1, so it is minus 18 minus 12 minus 4 into I1 minus I2 minus 6 into I1 minus I2 minus 5 into I1 minus I0 plus 10 is equal to 0. Same in loop 0, 0 loop. So current flowing I have taken as I0. Okay, or otherwise IN also you can take as per your wish. I have taken as I0. So because this zeroth loop, first loop and second loop, like that I have taken. Okay, you can also take as nth loop, I Norton's loop also you can take. So what is the equation? So current is flowing like this. So current is flowing from flowing through positive to negative. So positive to negative is drop. So drop is minus 10. So again, all resistance we are considering as drop. So minus 5 into I0 minus I1. Okay. So is equal to 0. So in loop 0, minus 10 into minus 5 into I0 minus I1 is equal to 0. So by simplifying this, minus, sorry, 5I1 minus 5I0 is equal to 10. So that is equation number 2. So two equations are there. Minus 15 I1 plus 5 I0 is equal to 0. And here it is 5 I1 minus 5 I0 is equal to 10. So while solving two equation, I1 we are getting as minus 1 amperes. I0 we are getting as minus 3 amperes. So I0 is nothing but I Norton's current. So I Norton's or otherwise I0 is equal to minus 3 amperes. So that means the current direction what we consider is wrong. So because initially we considered all the current direction like this. Okay, like this, like this, like this. But here, while calculating IN, it is coming as minus 3 amperes, like no. So current direction, what we consider is wrong. So it is like this. So current is flowing from A to B. Okay, not from B to A. Okay, so it is flowing from A to B. So the current direction, what we consider is wrong because it is minus 3 amperes. So now we are framing the Norton's equivalent circuit. So Norton's equivalent circuit, so IN is equal to 3 amperes. So in this direction we are taking. And the current is flowing like this because and R. So Norton's resistance also we are adding over in parallel. So Rn is equal to 3.33 ohms. So this is the nothing but the Norton's equivalent circuit. Okay, so across the A and B. So another method, easy method for calculating the Norton's equivalent circuit from the Thevenin's equivalent method is very simple. Okay, so this is one method of framing the Norton's equivalent circuit as per the Norton's theorem. So, say for example, if 5 mark question they asked, okay, so if the time is not sufficient, then you can go for another this method. This is a simplified method. Another way of finding the Norton's equivalent circuit from the Thevenin's equivalent circuit is, so Thevenin's equivalent circuit already framed. That is, so here where we frame, yeah. So here he already framed the Thevenin's equivalent circuit. That is 10 voltage here, RTH 3.33 ohms across the CN. So now we are converting this Thevenin's equivalent circuit into Norton's equivalent circuit by using the source transformation method. That means voltage source is there, that is connected with the series resistance is there. That is converted into current source with the resistance is connected in parallel. So like that method also you can go for. So what is I? How to calculate I? So I is equal to V by R. So V is what? 10 volts divided by R is what? 3.33. So if you simplify this, we are getting 3 amperes. So this voltage source is converted into equivalent current source. So that is nothing but Norton's current. That is IN is equal to 3 amperes. Okay, so that resistance should be connected in parallel across this point A and B. So like that also you can do. Okay, this is all about the Norton's equivalent circuits. So this is the Thevenin's equivalent circuit. This is a simplified method. This is one another method. Okay, if it is sometimes if they ask in 2 mark question or 5 mark question, uh, if you want to make it simple, then you can go for this method. Or if they told so you have to solve the Norton's theorem and find out the equivalent circuit, then you can go for the this previous method. This is also correct. The same answer only we are getting. So here also 3 amperes, 3.33 ohms. Here also 3 amperes, 3.33 ohms. So like this, you need to solve the problem. So circuit, it is, seems to be a difficult circuit, but you need to understand the circuit well. Okay, so first redraw the circuit. So say for example, sometimes for confusing also, they will give the circuit like this. Okay, in circular form, elliptical form, like that, and sometimes in a parallelogram from something for making it for making you very confusing mode, they'll frame the circuit like this also, but first you redraw the circuit as per your understanding, then it will be easy for you to solve any kind of circuits.